All right, we're going to continue to solve equations by factoring, and of course the directions, if you need some directions there, would just be to solve, right? That's what this would say, or solve the equation. So I'm looking at that and I'm going, interesting. Looks like x is going to be 0 for sure, right? Perhaps some other things. But what I want to do, when I see that I don't have terms with the same power, right? This is a fourth power and the second power. What I'm probably going to want to do is to get everything on one side. So I'm going to first move the x squared to the left, and I'm going to have x to the fourth, because these aren't like terms, right? They are not like terms, and so I'm probably going to want to try to factor if I can. So I have the x to the fourth minus x squared. Now I notice that there is a common factor, so that's handy. So I pull out the common factor of x squared. That leaves me with x squared, and then there's a minus 1 there. Let's go back and check. Is that times that? Good. That times that gives me that. Good. So now, here are my two factors. Actually, 4 factors, but they initially look like 2, so I'm going to have x squared is equal to 0. There's one of them. And then I have x squared minus 1 is equal to 0. So I'm going to take the square root of this one, right? And that's going to give me that x is equal to 0, right? Now, technically that would be considered a multiplicity 2, right? Multiplicity 2. Because we know we're going to have 4 roots in the real and imaginary realm. In other words, in the complex number system, we're going to have 4. So I'm going to go plus 1, and let's see here, we have x squared is equal to 1. Take the square root of both sides, and I'm going to have x is plus or minus 1. So there are the other two. So I have a 0, multiplicity 2, and I have a plus 1 and a minus 1. That makes the 4 that I knew that we had to have. All right, those all 4 just happen to be in the real world, not in the imaginary world. Let's take a look at another one that is a little bit more complicated, but it's just going to ask you to draw on some factoring that you may have learned, that you probably learned in Algebra 2, and it is called the difference of cubes. And so again, I'm going to look at this problem and it says to solve it, and so I see that I have terms with different powers. Okay, they're not like terms, so I'm wanting to get everything on one side. So I'm going to say minus 27x minus 27x. I'll have x to the fourth minus 27x, and that's equal to 0. Luckily, it looks like I have a common factor, so that's going to be x to the third minus 27. Now here's where your Algebra 2 needs to kick back in, and you need to recognize this right here as the difference of cubes. Now I'm just going to go over it briefly. If you want some more information, just search some YouTube videos for the difference of cubes as well as the sum of cubes. You just need to know it's the same pattern when it's difference or sum of cubes. I'll let you kind of look more of that up, but I am going to show you the factoring for this difference of cubes. Here we go. Here's my x. I'm just going to bring it down, and this right here is the difference of cubes is always going to factor into a binomial and a trinomial. So I'm going to set myself up 2 sets of parentheses, one small, one large, and then of course I'm going to finish my equation. Now what I like to do is I like to rewrite the difference of cubes as I'm going to put a little intermediary step in here, and that's going to be this. I like to rewrite them, both of the terms, as something cubed. So I rewrite 27. What cubed is that? That's going to be 3 cubed. Okay, so there it is. Here's what I'm going to have. This I call my A term, and this I call my B term. So every single time I have something that's a difference of cubes, I'm going to have it rewritten as an A cubed minus a B cubed. Okay, I just call that A and B. So the very first binomial that is going to come from that is going to be this, A minus B. All right, the second set of parentheses is going to be a trinomial. Now, there's a pattern, there's a rhyme to this, there's a reason to this rhyme actually, and I noticed that I've factored out an x, so what would make sense after I've factored out one of the x's, it makes sense that there would be an x squared remaining. If I've factored out a 3, it makes sense that I wouldn't have 3 to the third power. It makes sense that at the end I'd have 3 to the second power. So I'm going to plop those two in their little spots, and I'm almost finished. You'll find when you look this up, if you look it up on YouTube and just watch a couple of different authors do this, every single time the last term of the trinomial is plus, no matter what, whether you're dealing with sum of cubes or difference of cubes. Difference of cubes is what we're dealing with in this case. No matter what, it's the last term of the trinomial is a plus. Okay, now here's the cool thing about the middle term. Middle term is always the opposite of what we started with. We started with a minus, so the middle term is always the opposite. Okay, opposite. Always opposite of this first one. First one always matches the startup difference of cubes or sum of cubes. All right, now the middle thing that we're going to put in here, this middle one, is just going to be taking the yellow and the blue, the yellow and the blue numbers and scooting them together. In other words, I have an x and a 3. That's just going to be 3x. Isn't that handy? It's really simple. So there's your pattern. Some people would want to go ahead and rewrite it this way. Plus 3x, and then plus the 9. They'd go ahead and write that out. Okay, so let's finish this whole thing up. I have 3 factors. Let's set them each equal to 0. Now I'm going to tell you this, and you just need to flat take me at my word on this one. This last one here is not ever going to factor. It's always going to be quadratic, but it'll never factor. Never, ever. And so we're going to have to use the quadratic formula. So just take a deep breath and it'll be okay. So these two are finished. Let's go ahead and get the quadratic set up here. That's going to be the -3 plus or minus square root of over 2 times that 1 at the front. All right, we have the 3 squared minus 4a. A is 1. C is 9. So we have the x value is -3 plus or minus. Inside the radical, looks like we're going to get a -18. Let's take a look and see. That's going to be 9 minus 36. Is that right? Well, I certainly didn't do that correctly. That's a 27 in there. Okay, I don't know where I got 18, but okay. Maybe I was thinking of 9 minus, I don't know. Okay, here we go. Let's keep going. So this radical 27, we know that it can break up into 9 times 3, which can break up into 3 times 3. So it simplifies, right? 3 times 3 times 3 under the radical. I pull 2 out, which pulls out really one of them. So really I'm going to get 3 radical 3 there over 2. Okay, so there's nothing more I can do with that because it's there's an irrational number involved, and I need to leave it exactly in those terms. So these are my 2 other answers. So we have 1, 2, 3, 4, and we saw from the beginning that this was going to be going to have 4 roots, real or imaginary. There's going to be 4 of them. Okay, you're going, Miss Bell, why in the world did you not remember that was a -27? That's a -27. So sorry about that. Let's just looking at this going, wait a minute, that's an imaginary. So the -27 is going to be 3i square roots of 3. Pardon me for that. So there are your 2 answers there. In the 2 imaginary ones. It is a -27, so that's going to give me 3i radical 3. Okie doke. Hope this was helpful. Thanks a lot.